The driving force behind formation of a chemical bond is to attain an electronic configuration with a complete octet. The atoms attain a complete octet by giving, taking or sharing of electrons with each other. Chemical reaction. Some of the scientists of the 18th and 19th century carried out fundamental experiments on chemical reactions. They proved from their experiments that during chemical reaction, composition of the matter changes, and that change remains permanent. On the contrary, during physical change, only the state of matter changes, and this change is often temporary in nature. Triadics. Apparatus. Thermometer, evaporating dish, tripod stand, funnel, Bunsen burner, etc. Chemicals. Limestone powder, copper sulfate, calcium chloride, potassium chromate, zinc dust, sodium carbonate, phthalic anhydride, etc. Procedure. Carry out the activities 1 to 5 as given below. Read and record the temperatures in the activities 2 to 4. Point 1. Take a spoonful of limestone powder in an evaporating dish. Heat it strongly on a high blue flame. Point 2. Add zinc Zn dust into the copper sulfate CuSO4 solution. Point number 3. Add potassium chromate K2CrO4 solution to barium sulfate BaSO4 solution. Point number 4. Add sodium carbonate Na2CO3 solution to the calcium chloride CaCl2 solution. Point number 5. Phthalic anhydride in the evaporating dish. Close the end of the steam of a funnel with a cotton plug. Keep this funnel inverted on the evaporating dish. Heat the evaporating dish on a tripod stand slowly on a low flame. What did you observe in the funnel during heating? Chemical equation. Let us first look at a chemical reaction. In the activity 2, a colorless solution of zinc sulfate ZnSO4 is formed on addition of zinc dust to the blue solution of copper sulfate CuSO4. This chemical reaction can be written in brief as follows. Aqueous solution of zinc sulfate plus copper. This simple way of representing a chemical reaction in words is called a word equation. A word equation can be written in a further condensed form of using chemical formula as follows. CuSO4 plus Zn goes to ZnSO4 plus Cu. The representation of a chemical reaction in a condensed form using chemical formulae is called as the chemical equation. In the above equation, copper sulfate CuSO4 and zinc Zn are the reactants. They react with each other to form copper particles Cu and a solution of the colorless zinc sulfate ZnSO4. As the products having totally different properties, the ionic bond in the reaction CuSO4 breaks and the ionic bond in the product ZnSO4 is formed during the reaction. Writing a chemical equation. Let us now see the convention followed while writing a chemical equation. Point number 1. In a chemical equation, the reactants are written on the left hand side while the products on the right hand side. An arrow heading towards the product is drawn in between them. This arrow indicates the direction of the reaction. Point number 2. If the reactants or products are 2 or more, they are linked with a plus sign in between them. For example, in the equation 2, a plus sign is drawn in between the reactants CuSO4 and Zn. Similarly, a plus sign is drawn in between the products ZnSO4 and Cu. Point number 3. To make the chemical equation more informative, the physical states of the reactants are indicated in the equation. Their gaseous, liquid and solid states are indicated by writing the letters G, L and S respectively. If the product is gaseous, instead of G, it can be indicated by an arrow pointing upwards. The product form is insoluble solid in the form of a precipitate. Then instead of S, it can be indicated by an arrow pointing downwards. When reactants and products are in the form of solution in water, they are said to be present in aqueous solution state. This state is indicated by putting the letters AQ in brackets after their formula. Thus the equation 2 is rewritten as equation 3 shown below. 4 AQ plus Zn S goes to ZnSO4 Aq plus Cu S. Point number 4. When heat is to be given from outside to bring about a reaction, it is indicated by the sign written above the arrow that indicates the direction of the reaction. For example, the reaction in which slaked lime is formed on heating line stone is written as follows. CaCO3S goes to, it is indicated by the sign triangle written above the arrow that indicates the direction of the reaction. For example, the reaction in which slaked lime is formed on heating lime stone is written as follows. CaCO3S triangle goes to CaOS plus CO2 upward. Similarly, the fact that heat is released during the reaction between the aqueous solution of copper sulfate and zinc dust is indicated as follows. CuSO4 Aq plus ZnS goes to ZnSO4 Aq plus Cus plus heat. Point number 5. It is necessarily to fulfill certain conditions like specific temperature, pressure, catalyst, etc. to bring about some reactions. These conditions are indicated below or above the arrow indicating the direction of the reaction. For example, the reaction of a vegetable oil takes place at the temperature of 60 degrees Celsius with hydrogen gas in presence of the Ni catalyst and is written as follows. Vegetable oil L plus H2G 60 degrees C goes to Ni catalyst. 60 degrees C Ni catalyst goes to Vanaspati ghee. Point number 6. Special information or names of reactants, products are written below the formulae. For example, copper in reaction with concentrated nitric acid gives reddish colored poisonous nitrogen dioxide gas. Cus plus 4 HNO3 Aq goes to Cu NO3 to Aq plus 2NO 2 G plus 2H2OL concentrated. However, on reaction with dilute nitric acid, the product formed is nitric oxide gas. 3Cu in bracket S plus 8HNO in bracket dilute Q in bracket Aq goes to 3Cu in bracket NO3 bracket close 2 in bracket Aq plus 2NO in bracket G plus 4H2O in bracket S. Try this. Apparatus, test tube, conical flask, balance, etc. Chemicals, sodium chloride and silver nitrate. Procedure. Point number 1. Take sodium chloride solution in a conical flask and silver nitrate solution in a test tube. Point 2. Tie a thread to the test tube and insert it carefully into the conical flask. Make the conical flask airtight by fitting a rubber cork. Point number 3. Weigh the conical flask with the help of a balance. Point number 4. Now tilt the conical flask and mix the solution present in the test tube with the solution in the conical flask. Point number 5. Weigh the conical flask again. Which changes do you find? Did any insoluble substance form? Was there any change in the weight? A word equation is written for the above activity as shown below. Silver nitrate plus sodium chloride goes to silver chloride plus sodium nitrate. The above word equation is represented by the following chemical equation. AgNO3 in bracket Aq plus NaCl in bracket Aq goes to AgCl downward white plus NaNO3 in bracket Aq. Rate of chemical reaction. Take into account the time required for following processes. Classify them into two groups and give titles to the groups. Point number 1. Cooking gas starts burning on ignition. Point number 2. Iron article undergoes. Point number 3. Erosion of rocks takes place to form soil. Point number 4. Alcohol is formed on mixing yeast in glucose solution under proper condition. Point number 5. Effervescence is formed on adding baking soda into a test tube containing dilute acid. Point number 6. A white precipitate is formed on adding dilute sulfuric acid to barium chloride solution. It can be seen from the above examples that some reactions are completed in short time, that is, occur rapidly, while some other require long time for completion, that is, occur slowly. It means the rate of different reaction is different. Same reaction occurs at a different rate on changing the conditions. For example, during winter long time is required for setting milk into curd, while at the higher temperature during summer. The rate of setting of milk increases and the curd is formed early. Now let us see the factors which decide the rate of a chemical reaction, which is the reductant in this reaction and which reactant has undergone reduction. In this reaction, an oxygen atom goes away from CuO, copper oxide, which means that in reduction of copper oxide takes place, whereas hydrogen molecule takes up oxygen atom and water, H2O is formed, meaning oxidation of hydrogen takes place. Thus, oxidation and reduction reaction occurs simultaneously. The reductant is oxidized by the oxidant and the oxidant is reduced by the reductant. Due to this characteristics of the reduction and oxidation reaction, a single term redox reaction is used in place of the two terms. Redox reaction is equals to reduction plus oxidation.
Balancing a chemical equation. Complete the table aside on the basis of the equation. It is seen that the number of atoms of the elements in the reactants in this equation is same as the number of atoms of those elements in the products. Such an equation is called a balanced equation. If the number of atoms of each element is not the same on the two sides of an equation, it is called an unbalanced equation. Decomposition reaction. Try this. Apparatus, evaporating dish, Bunsen burner, etc. Chemicals, sugar, calcium carbonate, sulfuric acid, etc. Procedure. Take some sugar in an evaporating dish and heat it with the help of a Bunsen burner. After some time, you will see the formation of a burned out black substance. Exactly what must have happened in this activity? In the above activity, a single reactant sugar is divided into two substances, CnH2O. C12H22O11 sugar goes to 12C carbon plus 11H2O. The reaction in which there is only one reactant giving rise to two or more products is called a decomposition reaction. Try this. Apparatus, two test tubes, bent tube, rubber cork, burner, etc. Chemicals, calcium carbonate, freshly prepared lime water. Procedure. Take some calcium carbonate in a test tube, fit a bent tube to this test tube with the help of a rubber cork. Insert the other end of the bent tube in the freshly prepared lime water taken in the other test tube. Heat the powdered calcium carbonate in the first test tube strongly. The lime water will turn milky. We saw in the above activity that calcium carbonate undergoes decomposition reaction and the carbon dioxide gas formed turns the lime water milky. The second product of the reaction, the calcium oxide powder, remains behind in the first test tube. Similarly, in other reaction, hydrogen peroxide naturally undergoes slow decomposition into water and oxygen. CaCO3S heat goes to CaOS plus CO2 upward, 2H2O2 1 goes to 2H2O 1 plus O2 upside. We have studied in the previous standard that the water decomposes into hydrogen and oxygen gases on passing electric current through acidulated water. This decomposition takes place by means of electrical energy. Therefore, it is called electrolysis. 2H2O 1 goes to 2H2 upside plus O2 upside. The chemical reaction in which two or more products are formed from a single reactant is called decomposition reaction.
Displacement reaction. We saw in the beginning of this chapter that on adding zinc dust to blue-colored copper sulfate solution, a colorless solution of zinc sulfate is formed and heat is generated. See the equation for this reaction. From that we learned that the Zn square plus ions formed from Zn atoms take the place of Cu square plus ions in copper sulfate and Cu atoms. Formed from Cu square plus ions come out. It means that Zn displaces Cu from CuSO4. The reaction in which the place of the ion of a less reactive element in a compound is taken by another more reactive element by formation of its own ions is called displacement reaction. Endothermic and exothermic process and reaction. Heat is absorbed and given away in various processes and reactions. Accordingly, process and reactions are classified as endothermic or exothermic. Endothermic and exothermic processes. Heat from outside is observed during some physical changes. For example, point 1, melting of ice. Point 2, dissolution of potassium nitrate in water. Therefore, these are endothermic processes. On the other hand, heat is given away during some physical changes. For example, point 1, formation of ice from water. Point 2, dissolution of sodium hydroxide in water. Therefore, these are exothermic processes. In the process of dilution of concentrated sulfuric acid with water, very large amount of heat is liberated. As a result, water gets evaporated instantaneously. If it is poured into the concentrated sulfuric acid, which may cause an accident. To avoid this, required amount of water is taken in a glass container and small quantity of concentrated sulfuric acid at a time is added with string. Therefore, only a small amount of heat is liberated at a time. Do you know? Point number 1. One or more chemical reactions take place during every chemical change. Point number 2. Some chemical reactions occur at fast speed, whereas some occur at slow speed. Point number 3. Strong acid and strong base react instantaneously. Point number 4. In our body, enzymes increase the rate of physiological reactions. Point number 5. Perishable foodstuff gets preserved longer in a refrigerator. The rate of decomposition of foodstuff gets lowered due to low temperature and its freshness is maintained. Point number 6. Vegetables cook quickly on oil rather than on water. Point number 7. The chemical reactions are profitable in the chemical factories if their rate is fast. Point number 8. The rate of chemical reaction is important from environmental point of view as well. Point number 9. The ozone layer in the Earth's atmosphere protects the life on Earth from the ultraviolet radiation of the sun. The process of depletion or maintenance of this layer depends upon the rate of production or destruction of ozone molecules. Oxidation and reduction. Many types of substances give reactions called oxidation and reduction. Let us learn more about these reactions. 2Mg plus O2 goes to 2MgO, C plus O2 goes to CO2, MgH2 goes to Mg plus H2, CH3 minus CH3 goes to CH2 is equals to CH2. In the reactions, a reactant combines with oxygen, whereas an hydrogas is removed from the reactant. All these are examples of the oxidation reaction. The chemical reaction in which a reactant combines with oxygen or loses hydrogen to form the product is called oxidation reaction. Some oxidation reactions are brought about by use of specific chemical substances. For example, CH3 minus CH2 minus OH, ethyl alcohol, O, K2Cr, O7 oblique H2SO4 goes to CH3 minus COOH, acetic acid. Here the acidic potassium dichromate makes oxygen available for the oxidation of the reactant ethyl alcohol.
Such chemical substances which bring about an oxidation reaction by making oxygen available are called oxidants or oxidizing agents. Do you know a redox reaction takes place during cellular respiration? Here the molecule of the enzyme called cytochrome C oxidase helps the transport of electron to bring about this reaction. For more information, refer to life processes in the living organisms. Rancidity. When we use old leftover cooking oil for making foodstuff, it is found to have foul odor called rancidity. If food is cooked in such oil, its taste also changes. When oil or ghee is left aside for a long time, or fried food is left aside for a long time, it undergoes air oxidation and becomes rancid. Rancidity in the foodstuff cooked in oil or ghee is prevented by using antioxidants. The process of oxidation reaction of foodstuff can also be slowed down by storing it in airtight container.